Hey guys, so I've decided I'm going to try and make a video for how to properly space sprinkler heads. This is a question that I get a lot from fitters and apprentices alike, and unfortunately, it's not a very easy question to answer. There are a lot of variables involved when we start getting into obstructions and spray patterns and stuff like that. But that being said, there is a proper way of spacing them based on hazards and stuff like that. And I'm going to get into it. I'm going to just give the most basic explanation that I can, just based on smooth, flat ceilings, no obstructions, no issues with lighting layouts, HVAC, all that kind of stuff. So um, I'm going to add lots of timestamps to this, but I think the best way of doing this is to actually start with a little bit of code background. We definitely need to kind of cover some things just in case. I don't want to just start jumping into spacing things and not sort of give an explanation as to why things are the way they are. So I've done my best to organize my thoughts, organize which codes I thought were the most relevant for making this explanation as simple as possible. So all the code references I'm going to give are based off of NFPA 13 2016 edition. So you can see that right here. So without further ado, we're going to get into it. All these codes are straight out of that code book. I've just kind of took a little snippet of them. And one thing I would like to sort of talk about when it comes to code and sort of dissecting it and understanding how to read and interpret code is you need to know what all these number sequences mean. And basically it breaks down to chapters, sections, subsections, clauses, and subclauses, and so on and so forth. So if I were to just kind of quickly explain that, we've got all of our chapters right here, right? And you can go to our table of contents. If I kind of scroll down, where are we? Table of content. There we go. Table of contents, and these are all of your chapters. So if I were to just pick a chapter, system requirements, then we've got a section which is just wet pipe systems, and then we've just got subsections of pressure gauges, and so on and so forth. Okay, so everything I'm going to be showing you today I'll give a code reference, and one thing I really do like to stress for everyone to kind of get into the habit of is when you start giving code references, or when you're looking in the code book at code references, try to work your way backwards, because there are a lot of codes that repeat themselves. However, you might be looking at a code which you think is the answer you're looking for. And then as you start digging backwards, you realize, okay, I'm in chapter 8, that's installation requirements. I'm in section 2, which is system protection area limitations, and then you might be into another subsection, which might be specific to, say, for example, sidewall sprinkler heads. Meanwhile, the code you were looking for is for standard spray upright heads. So this video, I'm only going to be doing standard spray uprights. I don't have enough time to get into everything, by the way. I can't go over every single chart. So again, this might be a bit of a long video, but it's necessary. So anyways, like I said, I've tried to always include basically the breakdown of these codes. So as you can see, system protection area limitations, that's right here. So that is the section of the code, and installation requirements is actually the chapter. So that's chapter 8, installation requirements. So I just quickly prove that to you. I might do this a few times. But there you go, chapter 8, installation requirements. And so like I said, this came right out of this, and the red highlights are always basically just a direct reference, just to break it down so we can work our way up, and I'm not pulling codes out of my butt. So anyways, I think this is the best way to start. First thing to talk about is the system protection area limitations. So this is basically the maximum area of protection per system, depending on the hazards. So we've got light hazard, ordinary hazard, extra hazard, storage. And they're just giving you what your limitations are. You cannot have a system larger than this size. Now, there will be subclauses when you get into like mezzanines and all this kind of other stuff, but this is just a basic introductory. This is just kind of the general code for it. So if you have a light hazard zone, say for example, actually, I'm not going to give you an example just yet. We're going to get into them. But if I were to have a flow switch, my one flow switch can only monitor a system size no greater than this. That's kind of the gist of this, okay? So I'm going to move on. Then this is just a classification. I'm not going to read all of this to you. You can feel free to screenshot all of this to you if you wish. But this is just a quick general description of what each hazard occupancy really is. So it kind of gives you a breakdown. It doesn't give you any examples, but that's going to be coming up. So I'll just read the first one to you. Light hazard occupancies shall be defined as occupancies or portions of other occupancies where the quantity and or combustibility of contents is low and fires with relatively low rates of heat release are expected. And then everything just kind of escalates as we get into ordinary hazard group 1. It's just basically saying, moderate and stuff like that, right? Quantity of combustibles is moderate, stockpiles, blah, 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 blah. So I'm not going to read all this to you. Feel free to screenshot it just so you can kind of read through it and kind of understand what each of the different classifications of occupancies and commodities are. And then I'm actually going to give you some examples of what each hazard occupancy is, because this is actually very important. People don't realize as they walk into certain areas, they don't realize that the hazard occupancies change. So here's the next one. This is from the annex of the codebook. So if you ever, actually I should have said this. If you see this little asterisk here, that little star, that means you can go to the annex of the codebook. So 5.2, there's A5.2, the very back of the codebook, and it gives you basically additional information on the code. If you ever get the handbook version of any kind of codebook, that information is actually located right below. They don't have the annex. They actually give you all that information right away. So if you can get your hands on a handbook, they're fantastic. It kind of saves you kind of flipping back and forth. It just kind of makes it like a dummy, blah blah, like whatever for dummies basically is that kind of code book. So it's great. It really does kind of simplify the language a little bit. When I say blah blah, I just meant they make handbooks for every code book. So whether it's NFPA 13, 25, 20, whatever, there's a handbook for it, and it just kind of it breaks it down for you nicely. So anyways, here are some examples of light hazard occupancies, and this obviously isn't a full list. It's just some examples for you to kind of go off of. So as fitters, I kind of like to, how do I put this? This is kind of more the designer's job. When you get a designer, you get a stamped drawing from an engineer, designer and engineer. When you get a stamped drawing, they will know what hazard occupancy they are designing the sprinkler system to. And it's not always just based on what the area is, but it can also be based on the commodities within the area being protected. So, you might have, here's actually a perfect example, light hazard occupancies, and we've got libraries. A lot of people think libraries are, oh, these are tons of books, paper, there's paper everywhere. It's going to go up in flames. It needs extra protection. You need lots of water to put out a fire in a library. Well, no, that's not true. And light hazard occupancies, because of the commodities that it is and that the height of storage, so that's actually considered a light hazard occupancy right here. Libraries, except for large stack rooms. And then as we get into ordinary, I think it's ordinary 2. Yes, ordinary 2, libraries, large stack room areas. So again, that kind of just proves it depends on the commodities that are being stored that will kind of bump the designers and engineers to change the hazard classification that they're designing to. It'll change the water density that they're trying to achieve. So again, I don't really like to get too much into this, but I do think this is worth noting because it kind of just gives everyone a bit of a little bit of a mental flashbang as they start installing, they go to different areas. It's good to be aware of the general hazard that you're working in. So when you're spacing heads, you know roughly what you should be doing because sometimes we're not given drawings and we're just kind of sent there like cowboys to say, oh yeah, go add some coverage over here. And there's no permit, there's no nothing. We're just kind of sent there to figure it out for ourselves. And we obviously want to do the right thing. And I'm not saying that's right. Every job really should have a permit because this is not our job to do math and calculations and all this kind of stuff. But we do get stuck with it. It's part of the job. So that's kind of why I thought this video was going to be very handy. So, and one thing that is worth noting is mercantile. That I really do want to stress that. This is a very common thing. So mercantile is basically any area, any place of business that, kind of sells commodities, like a mall. When you walk into a mall, you walk into Walmart. This would be the sales floor of Walmart or Target or any other store that you go into. However, typically the actual mall common walking area, like, just the area in the middle of a mall, that's just a tile floor and you got your escalators through there and all that. That's typically considered a light hazard occupancy. And that's just because there's no commodities it's really protecting. It's just tile floor, maybe a couple of, odd trees that they got in there, a little bit of decoration. But for the most part, there's nothing. It's very a lot of like non-combustible construction and stuff like that, and not too many commodities being stored there. So the mall common area is typically light hazard, whereas the moment you step foot into a store, the store itself now is mercantile, and that falls under ordinary hazard group too. So that is kind of one thing. It's a very common thing for us in sprinklers where we don't realize that, and we always kind of say, oh yeah, it's a store, whatever, 7'6" off walls, 15 feet between heads, and that might not always be the case, and we're going to get into that. So okay, we are now into installation requirements: position, location, spacing, and use of sprinklers. Now this is kind of the this is the meat and potatoes of this lesson, really. And the biggest thing that I kind of want to point out, so again, I've just kind of, as you can see, position spacing 8.5, that's my my section right there, position spacing. Installation requirements, we're still under the chapter 8 installation requirements. So that kind of makes sense. Let me see, how do I do this? I'm kind of on Zoom here. This is my first time kind of, let's just go with the draw tool. That's cool. So yeah, I really just wanted to emphasize this section right here. This is kind of really what I want everyone to kind of focus on. And we are actually going to go through this. I'm going to read this to everybody. All right. So bear with me. Okay. The protection area of coverage per sprinkler, AS, shall be determined as follows. Along the branch lines, as follows, determine the distance between sprinklers or to the wall or obstruction in the case of the end sprinkler on the branch line, upstream and downstream. Now this one's important. Choose the larger of either twice the distance to the wall or the distance to the next sprinkler. Now that's a key thing right there. Choose the larger. Oh, I can't try. Okay, of either twice the distance to the wall. I'm going to delete that. I know, I'm sorry. Or the distance to the next sprinkler. All right, let me undo that. I just want to emphasize that. Define dimension as S. So that's S right here. Okay, and I'm going to undo this again. Between branch lines as follows. So this is along branch lines. So that would be this from here. That's along the branch line. Sprinklers along the branch line. And then what it meant by be choose a larger of either twice the distance to the wall or the distance between the next sprinkler. So I think now is a good time we sort of get into here. So if, for example, this distance, actually here, I already put arrows here. What am I doing? If this distance is 15 feet right here between sprinkler heads, and let's say from here to here, same thing, 15 feet. And let's say, for example, this sprinkler head to this wall, these are all typical. Let's say this was only 4 feet. Well, that code is basically saying, choose the larger of either twice the distance to the wall or the distance to the next sprinkler. So twice the distance to the wall. If that's 4 feet, then 4 feet times 2 is 8 feet. But then the distance between these two sprinklers is 15 feet. So what's bigger, 8 feet or 15 feet? Well, obviously 15 feet is bigger. So we're going to go with 15 for our S dimension in this scenario, right? Twice the distance to the wall or between sprinkler heads, whichever is the larger dimension. All right, that's key, very key to remembering this kind of stuff. Delete all of this. Cool. And then between branch lines as follows. This is basically the exact same thing as what's above. However, instead of along the branch line, it is basically saying between branch lines. Now we're going left to right, or on the x-axis here. So same rule applies for B. Choose the larger of either twice the distance to the wall or obstruction, or the distance to the next sprinkler head. So let's do the same thing. Let's say, for example, between this sprinkler head here and this sprinkler head here, we've got 12 feet. Let's say, for example, between these two here, we've got 14 feet. And then let's say, for example, between this sprinkler and the wall, we've got 7 foot 6 inches. Oh my God. Well, twice the distance to the wall, 7 foot 6 times 2 is 15 feet. So let's say times 2 equals 15 feet. And then we've got 12 feet between these two branch lines and then 14 feet between these two branch lines. Well, which one's the largest one? We got 12 feet, 14 feet, and 15 feet. So this, in this scenario, if this was my existing installation, or this is what I'm installing in the real world, this would be my L dimension right here. So 15 feet is what I would use. So I hope that makes sense, okay? And then the protection area of coverage of the sprinkler shall be established by multiplying the S dimension by the L dimension. So I can't remember what number I used up here. I think I just used something even, but let's say, for example, I'm going to just give numbers again. Let's say, for example, this was 6 feet to, oh man, let's delete that last one. This is terrible. I am not good at, oh my God, here we go. Let's say that's 6 feet, and let's say this is, I'm going to go with 10 feet. 10 feet between these sprinklers, and then between these two over here and here, we're going to say it's a 10 feet again. 10 feet. Well, based on this chart, if I've got 6 feet and 10 feet, I got to multiply this distance to the wall by 2. So 6 times 2 equals 12 feet. So what's bigger, 12 feet or 10 feet? Well, 12 feet is bigger. I'm going to ignore this wall. We're just going to pretend this one doesn't exist, just because I don't want to go off of a million different walls here. I figured just the north, west, and east wall on this photo is good enough. So my area of protection would actually be 12 times 15. So in this, that is, it doesn't matter that all these other heads are spaced closer. That's 6 feet to the wall. These two heads are 10 feet. It doesn't matter. I have to treat it as 12 feet by 15 feet. So if I were to bust out my handy dandy calculator here, so if I've got 12 times 15, my sprinkler area of protection is actually 180 square feet. That's what it would be for this job. All right, so that is how you calculate the protection area of this zone. Okay, so that is very important, the lessons that we just learned here, okay? I'm going to clear all this stuff. Cool, so we've now established all of this. We're going to move on to the next this one's not super important. I think I kind of got lost in my own thoughts here as I was copying and pasting. There are so many codes to go off of. And like I said, I want to keep this simple. This is basically just reiterating what I just kind of explained. It shall be measured along branch lines, but maximum distance between sprinkler heads. The maximum distance permitted between sprinklers shall be based on the center line distance between adjacent sprinklers. So adjacent sprinkler from the center. I didn't do a good job of drawing these arrows here. I kind of wish I put them, I wish I put these arrows right in the middle of this branch line right here, but I kind of screwed that up. But it is basically from the center of this sprinkler head, very center, to the center of this sprinkler head, and vice versa. So the center of this one to the center. I did a good job showing it on this one. Actually, here, let's do this. Center to center. So center to center. It's always center, center. That's how we measure sprinklers. Maximum, the maximum distance shall be measured along the slope of the ceiling. That's actually good to document as well. That's probably why I did this. So basically, where do I draw this? If you had a sloped ceiling like so, let's pretend this is kind of like a Butler building, and we've got our sprinkler heads installed like this. There's a sprinkler head right there. There's a sprinkler head right here. Oh God, I know I can't draw for beans. We would measure along the slope. We don't measure, oh, I can't draw this one. I can't measure horizontally along the x-axis. That's all I'm trying to sort of explain. So if this were kind of if I had a point laser on the floor, and I put a laser right underneath this sprinkler head and a laser right underneath here, well, if I measured along the slope and I measured 6 feet on the slope on the diagonal, but then I put a point laser on the floor, I would get less than 6 feet because I was measuring along the slope. So we measure along the slope, not along the actual horizontal axes if the ceiling is sloped. That's all that's saying. All right, so let's clear that. The maximum distance permitted between sprinklers shall comply with the value indicated in the applicable section for each type or style of sprinkler. That is important. So again, as I just mentioned earlier in the video, this does get very messy when it comes to quoting codes. As you can see, like, look how deep in we are. Like, look at this, 85311. Now, and they get worse than this, right? It just becomes alphabet soup for numbers. Basically, what that means is each section is going to have its own set of code. So there will be its own max. It's basically saying the maximum distance permitted shall comply with the value for the applicable section. So if I am talking about standard spray upright sprinkler heads, this is basically telling you the maximum only applies to that section. The maximum in standard spray sprinklers of the code only applies to standard spray sprinklers. And I don't know if I can just quickly find it. I think it's just kind of worth showing you. And the reason that, again, that I think I already mentioned it, but codes can kind of seem like you might think you found the right answer to something. However, what you might have actually just found a code that is just repeating itself. It's the same answer no matter what it is, however, you might be looking at, say, for example, an ESFR head, and the code might say, oh, it's 4 inches minimum to a wall for an ESFR head, but that same code is also the exact same for a standard spray upright. And basically, what it means is you need to just make sure you're looking at the right section of the code. So how do I get in? Let's scroll down here. Just to kind of show you what I mean by the different sections. Where are we? Oh, I'm somewhere here because we're looking at obstructions. I am so sorry. I probably should have kind of, oh, right here. Okay, so 865, obstructions to sprinkler discharge, standard pendant and upright spray sprinklers. Now there's going to be another code that's going to be obstructions to sprinkler discharge, but in brackets, it's now going to say standard sidewall, horizontal sidewall and vertical sidewalls. And then there'll be one for extended coverage sidewall and extended coverage upright and pendants. And I'm just going to just scroll down just to kind of show you what I mean right there. Extended coverage upright. Oh, yeah, look at that. That was a complete guess, and I found the exact same. So that's what I mean. So it can get very convoluted. When you are going to give anyone a code reference, you need to make sure you backtrack. So whatever code you found, look at whatever subsection, whatever section you're on, and work your way back. So 851. Well, what does 851 mean? That is performance objective. So what does 885 mean? 885 is obstructions. What does 88 mean? So now I need to scroll up and find 88 specifically. What are we talking about when we refer to chapter 88? Or section 88. I probably lost it. It's right here. Extended coverage upright spray, upright and pendant spray sprinklers. And then chapter 8 itself is just installation, right? Installation requirements. So that's what I mean. That's what that code meant when I kind of pointed it out by it's specific to its own sections, right? Oh, this is another good thing that's worth pointing out. Again, sorry, it's very easy to go off on a tangent on stuff like this. There's so many codes and there are many things that I kind of feel are worth noting. So the minimum distance shall be maintained between sprinklers to prevent operating sprinklers from wetting adjacent sprinklers and to prevent skipping of sprinklers. And what it means by wetting agent adjacent sprinklers, basically what it means is they want to prevent what's called cold soldering. And I think we've all heard at this point that the minimum distance for standard spray upright and pendants is 6 feet minimum, unless there is something to obstruct the discharge. So once we get into obstructions, that's a whole different cat. But basically, if this head were to go off right here in the middle, right? If that head were to go off and I were to space this head, we know the minimum distance as per NFPA 13 is 6 feet. But let's say I installed it 5 feet. Here's my branch line, there's my sprinkler head. What if I installed this 5 feet, right? Now I've gone less than the minimum per code. And if a fire were to start right here, let me see if I can change my color right here. If a fire were to start, say, right here, right in between where I drew this branch line and this branch line, fire were to start, let's say this head goes off. Well, this one, the water spray, is going to spray on the thermal element of the next head over, and it's going to cool it down, which means this head will never go off. So whether it's a frangible bulb, soldered link and lever, or fusible link, doesn't really matter what it is. If that gets wet and it gets cooled down, well, sorry, I'm circling the wrong one. It would be this one. But if it cools down, then it basically will not go off. And then it's going to take longer. And eventually this other head, which is spaced far enough away from this branch line, will go off. But now we've got that one head that was skipped because we installed that head too close. So that's basically what that means. We're trying to prevent cold soldering from happening. We don't want one head right underneath the fire to go off and then the next head beside it to not go off because it's getting cold soldered by the adjacent sprinkler, right? The minimum distance permitted between sprinklers shall comply with the value indicated in the applicable section. Same thing as what I mentioned up here with this code up here. So we're just repeating ourselves at that point. All right, so that's basically why I wanted to touch base on this code. I thought it was worth talking about for a quick second. Okay, we are now getting into charts. I talked about calculating the maximum protection area of a sprinkler head, about twice the distance off a wall, and that kind of doodads. Now we are looking at a couple of different charts here. There's actually 1, 2, 3, 4 different charts here. We've got protection areas and maximum spacing of standard pendant and upright spray sprinklers for light hazard. I'm going to highlight that the best that I can. Can I just draw a line? Oh, dope. Let's draw a line. Oh, I don't have to. Oh, yes. Light hazard. That's what I'm talking about. There we go. And then we got ordinary hazard. I should have been doing lines rather than trying to freehand this thing. Extra hazard over here. And then we've got high pile storage. Now, I'm not going to go over this whole chart in all of its glory, but we are going to talk about them just so everyone understands what this chart is conveying. So let's start right from the very beginning. I've already explained we got a few different charts based on the hazards, right? The type of hazard occupancy. And then we've got construction types. This is pretty straightforward. So we've got non-combustible, unobstructed construction for a light hazard occupancy, right? That's pretty straightforward. And then as we kind of go down the list, we've got combustible, unobstructed with exposed members. So that could mean beams, joists, whatever, but it is combustible. So that would probably typically mean it's like a wood joists or something like that. Unobstructed with exposed members 3 feet or more on center. So I don't feel like I need to explain that. It's pretty self-explanatory, right? Combustible, unobstructed with exposed members 3 feet or more on center, same thing. What was this one? Unobstructed with exposed, unobstructed with exposed. Oh, the difference was this one's hydraulically calculated. That's why. It's like, why am I reading the same thing twice? Right. So anyways, it's very straightforward as to what type of construction it's talking about for each one. I'm not going to get into that. But I am going to get into system type. Now, this is just jumping back and forth between hydraulically calculated and pipe scheduled. So in the beginning of the video, I mentioned how this isn't really our job to do these kinds of calculations. This is what lands on the engineer and designers, but we kind of get stuck with it. These terms get thrown around a lot. in the field. A lot of guys will hear, oh, I've heard hydraulically calculated, I've heard pipe scheduled. And I know when I was an apprentice, I know a lot of guys everyone would always say, oh, you're allowed to take 2 heads off the 1 inch, 3 heads off 1.25 inches, 5 off 1.5 inches, 10 2 inch, blah, 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 so on and so forth. And that was basically referring to what's called a pipe scheduled method. That is a very old school method where basically they just said there is a certain pipe size and you are allowed to take a certain amount of sprinkler heads off of that pipe size. So, and that's basically what it was. So I'm going to quickly jump to a chart. Oh, what's going on here? There we go. Let's delete all of this, clear our drawings. So here is the definition of a pipe schedule system. I should have actually just jumped to this before I started explaining, because I already did the work for myself. A sprinkler system in which pipe sizing is selected from a schedule that is determined by the occupancy classification, and in which a given number of sprinklers are allowed to be supplied from specific sizes of pipe. Now, if you are wondering, if you ever go up to a sprinkler system and you're at the alarm valve and you're wondering, well, how do I know if this is a pipe schedule system or if it's hydraulically calculated? There is what's called a hydraulic data plate that must be secured to the riser. And I've gotten to the argument with people where they're like, oh, well, what if it's pipe scheduled? That hydraulic data plate must also, if it was pipe scheduled, there still has to be a data plate on there, and that data plate must say this system was designed as per the pipe schedule system. So no matter what, at your alarm valve, there will be a data plate, or there should be a data plate that will tell you whether or not the system was hydraulically calculated or pipe scheduled. All right, so, and if you don't see that data plate, then you get to slap the inspectors on the wrist, because that is part of the quarterly inspections as per NFPA 25, to make sure that the data plate is there, legible, secured, all that jazz, right? So anyways, I couldn't give you a better definition. It's right there. And then just to sort of explain, again, this is what every fitter ends up telling you over time, all the old school fitters. Oh, let's not do that. That was blurry. They tell you, oh, okay, you got 1 inch pipe, you're allowed 2 sprinkler heads off the 1 inch. You have 1.25 inches, you're allowed 3 sprinkler heads off of that, and then 1.5 inches, 5 off of that. So that is based on a pipe schedule method. Okay, so say for example, back in the day, back in the whatever, I don't know how long ago they did it, probably in the early 1900s or something like that, 1910, 20, 30, whatever, they would do the pipe schedule method. So they would come in with a 3-inch main spigot into the building, and they basically just said, hey, with a 3-inch main, I'm allowed a grand total of 60 sprinkler heads off of it. So if I were just to, I'm going to quickly explain. Should I? Yeah, I will. Forget it. I really didn't want to, but I guess we will. So say, for example, this is a 3-inch main, right? Supply main, right here. Well, 3-inch main, I know I'm allowed 60 sprinkler heads, but off the main, I've got 3 branch lines. Well, my branch lines, I now know, because it's a main, I'm allowed a grand total. Oh, geez, what did I do? 3-inch equals grand total of, what did I just say? 60 sprinklers. Oh, I'm going to just cover everything up. Oh, that's cool. It went transparent. So, and then if what they might do is they might install a 2.5-inch branch line over here. So let's say 2.5 inch equals 30 sprinklers, grand total. Let's just say 30 sprinklers. So out of this, the only reason I'm doing this is to sort of explain. So this is my main. I'm allowed a total of 60 sprinkler heads off of it. I've now run a 2.5-inch main, and I want to max it out. There's going to be 30 sprinkler heads on this branch line. Well, out of my other 2 branch lines, I am now only allowed to install 30 more heads, because my main was only ever calculated to, or pipe scheduled, I should say, to allow for a total of 60 sprinkler heads. So now let's say, for example, they wanted to install a 2-inch branch line over here. Oh, 2-inch branch equals 10 sprinklers. Oh, wow, I can't spell. There we go. And now we're at a grand total of 40. Typically, you don't install, I'm basically saying on this main, there are no sprinkler heads directly off the main. They've only taken heads off the branch line. So they took a total of 30 off this one. They're taking a total of 10 off this one. That leaves me 20 heads left. Well, let's say they want to install another 2.5-inch main. 2.5-inch branch line. On this branch line, I'm only allowed 20 sprinklers. And that is because I've already maxed this one out at 30, that one out at 10. So I'm at 40. And then even though this is a 2.5-inch main, I can't install 2-inch because I can only get 10 off of it. But then they would say, okay, we'll run 2.5 again, and we'll take 20 heads off of this final branch line. And that gives us our total of 60 heads. And then if someone screwed up, they needed one extra head somewhere, well, too bad, so sad. You've only got a 3-inch main. You're not allowed to install any more heads off of that main. No more branch lines, no more heads. That's it. Game over. You're going to have to beef up the size of your main at the incoming of the building. So that is basically what pipe scheduling is or was. And we really don't do it anymore these days. There are circumstances in NFPA 13 where you can, but we really don't do it. Oh, shoot, how do I get out of this? Let's get out of that. Okay, so that was, and it depends on the hazard. So if it's a light hazard installation, you can see the number of sprinklers change. And it also tells you based on the material you're using. So if this is steel pipe, the numbers I was just giving you was based off of steel pipe, but I mean, you are allowed to install copper sprinkler systems. I have seen one once in my life, but with copper, you're allowed to install more heads, and that's just because the friction loss is much less on copper. The Hazen-Williams friction loss is so copper has much better hydraulics than steel does, and that's basically what that is. So if this were an ordinary hazard, if this was a mercantile zone, then I would have to use this chart, and that's basically that. So anyways, so let's go back, and then I'm going to talk about hydraulically calculated, and that basically just means a designer or an engineer has actually they've looked at the calcs, they've looked at what incoming pressure you have in the building, they've done their flow tests on the hydrants outside of the building, they've got their pedo readings, they know what they've got all of their criteria, their mathematical criteria, and they will calculate everything accordingly. So they might actually just say, you know what, based on this system, I only need a I'm just going to go drastic here. I'm going to say I only need a 2-inch supply main and 1.5, let's say 1.25-inch branch lines, because my incoming water supply is 150 psi. There's a pump house right outside the building, and that's all I need for this system because the math works out. And this kind of leads me into the next biggest thing that every guy kind of ends up asking. They say, well, I need to add a sprinkler head. Am I allowed to install it off of my branch line, or do I have to go off of the main? Now, right? So if this is a 2-inch branch line right here, they've installed 3 heads off of it. This is a 4-inch main. I'm just picking numbers here. It really doesn't matter. But the original drawing showed 3 heads off the 2-inch branch line with the 4-inch main. And I need to add an extra head right here in this spot. Can I drill off the 2-inch and just come over? Or do I have to drill off the 4-inch and come over? That's what everyone ends up asking, because they're like, this way, I only need 2 feet of pipe, right? A 2-foot break arm. And that showed as 21, but it was supposed to be 2 feet. Whereas I just can't do my ticks right. Whereas coming off the main, this is 60 feet of 1-inch, right? And no guy wants to go and drill a 4x1 Mac T and run 6 lengths of 1-inch all the way over here to do that. But the question is, which one's better? What's allowed? Am I allowed to come off the branch line, or should I go back off the main? The answer is I can't tell you. If it's hydraulically calculated, the designer must do the math. They got to figure this out for you. So if you have a good designer and you're kind of doing a new construction, new build or whatever, one thing I usually do like to ask them is just say, hey, I know you installed that, I know we got a 4-inch main. I know I've got 2-inch branch lines, and I see that you've installed 3 heads on that 2-inch branch line. Am I allowed to exceed that? And if so, how many heads can I take off of that branch line before I have gone over on our calculations and I got to run a new branch line or whatever? So if you just kind of want to save some time, you already kind of know you're going to run into issues like that, ask them the question ahead of time just to kind of get that answer. So unfortunately, I'm not much help in that one, and no fitter will be. You need to, when it comes to hydraulic calcs, that's all there is to it. You need to have someone do the calcs, do the math for you. That they will tell you what's acceptable and what is or is not acceptable. All right, so now I've explained system type. Now we are going to get into this. This is the real reason everyone was kind of here, but it took a little bit of explaining before I can get us here. So we now have a maximum protection area where, again, this is light hazard, maximum protection area, and we have a maximum spacing chart over here. All right, so same thing, ordinary hazard, extra hazard, extra hazard. Oh, this is high piled storage hazard. And it's the same thing, protection area, the charts are typical. Now, maximum protection area, we have all heard you can install heads a maximum for standard spray upright and pendant. We've heard that you can install heads 15 feet between each other and no greater than 7'6" off a wall. Well, I've already kind of explained off of the wall. So if we're 7'6" off of a wall over here, right? 7'6", and we are 15 feet between sprinkler heads. Well, that just means, and we said the distance off a wall times 2 is equal to 15. Well, it's the exact same thing. Whichever is greater, well, they're equal. So 15 is your answer. So let me clear everything, clear all. So if we go into, where is my calculator? There it is. So if we get into maximum protection area for a hydraulically calculated light hazard system, we've got 225 square feet and the maximum spacing is 15 feet. So that basically means if I were to install my heads 15 feet along the branch lines, multiplied by 15 feet between the branch lines, left and right, so on the X and Y axes, I'm getting 225 square feet. That's awesome. It's hydraulically calculated. My maximum protection area does fall under 225. So that being said, on a light hazard installation that's been hydraulically calculated, that is non-combustible, unobstructed construction, I can indeed install my heads 15 by 15, no greater than 7'6" off a wall. I'll get into small room rule at some point, but we're not going to talk about that right now. So there you go. So 225 works. Now let's, if we start, but now if we're going to get into light hazard, same thing, light hazard. Let's do hydraulically calculate. Oh, hydraulically calculated is always 225. We don't get into it. Let's do light hazard, but combustible, unobstructed, members less than 3 feet. Let's go to this chart right here. Oh man, I'm not right here. We're gonna go with this one right here. We're at 130 square feet. Combustible, this one. This is the one we're gonna go off of. Now let's look. Our maximum spacing here still says I'm allowed to be 15 feet, but right here, 15 feet. However, my maximum protection area has changed to 130, right? So this is still light hazard, but now whether or not it's pipe scheduled or hydraulically calculated, I have to maintain 130 square feet. So if I wanted to stick with a maximum spacing of 15 feet, I cannot install 15 feet this way. So let's say this is 15 feet between heads. And let's say let's pretend this is typical, another 15 between heads along the branch line, right? I should have drew one more arrow here. I did not, but that's okay. You know what I'm talking about. So if I'm going 15 feet this way, well, I can't install them this way 15 feet as well, because as we just figured out, 15 times 15 is 225 square feet. So that is no bueno. I can't do that. Oh, go away. So how do I get my 130? Very simple. Now we just got to bust out our calculator. We are going to go with 130 divided by 15, and that gives us 8.6 bar, 8.6 continued. So that means 8 foot, let's minus our 8 feet, times 12. These are our decimal inches. 8'8". That means if I want to maintain 130 square feet and I'm going to max out one side at 15 feet, right? Let's erase. Where's my eraser tool? Right here. Get rid of you. So I can only be, if I'm going to go 15 feet between heads along the branch line, then between branch lines, I can actually only install my heads every 8 foot 8 inches between branch lines. And that is going to be the same rule all the way across. So 8 foot 8, that means again between here, 8 foot 8 inches. Oh, I should have, too late. You know what I meant. I meant to put a hyphen in there. But now we get to our wall. Ooh, now what can I be? Can I be 8 foot 8 off the wall? Well, we know that. Can I be 6 feet off the wall? Well, I just explained before, if I go 6 feet off the wall, I need to pretend it's 6 feet times 2, which would be 12 feet, and I have to pick the larger dimension. So I've got 8 foot 8, 8 foot 8, and if I went 6, then I have to treat this as 12. So that means if 8 foot 8 is my maximum to obtain my 130 square feet, that would mean 4 foot 4 inches off of the wall is my maximum dimension I'm allowed to be. And now just to prove this again, that we did indeed achieve our 130 square feet, we're going to go 8.666666666 bar multiplied by 15 feet. Bam, 129.999 feet, square feet. So that is our area of protection, right? Does that make sense? I probably shouldn't have drawn these in here like that. So I'm actually glad I jumped onto this one for light hazard, because I really actually like to use this 130 for ordinary hazard. And this is because this is such a common issue that, let's say, for example, we weren't going off of light hazard here. We're actually going to pretend this is ordinary hazard. And we know ordinary hazard, as I look down it, it's still, ooh, yeah, the chart stays the same. So it's a protection area of 130 square feet, right? 130, or an ordinary hazard. 130 square feet, and my maximum spacing still stays at 15. But that doesn't mean I can install them 15 by 15, as I just showed you over here. All it means is I now need to make adjustments, right? So I can only be 15 feet this way, 15 feet max. And then again this way. I really wish I drew one more arrow. And just for schnitz and giggles, I'm going to say, what are we allowed to be off the wall? Well, for 15 feet along the branch lines, well, off the wall, 7 foot 6 inches off the wall maximum is appropriate. We can still be 7.6 off that wall. Same thing with this south wall, but it doesn't matter. So yeah, that really does kind of break down how you space them. And this is, again, just based on no obstructions or anything like that. I think I'm going to give you one more example. Let's pretend, so my intention of doing this, I kind of got ahead of myself. Let's clear everything. My intention, let's say this is going to be a hydraulically calculated system. So I'm going to circle this bad boy right here. Hydraulically calculated hazard occupancy. I want this to be ordinary hazard group 1. Not that it matters, because the chart stays the same anyways. All right, so now that's that. I'm going to give a dimension up here. Let's just let's go with 27 feet. Sure, let's go with 27 all the way across. Who cares about this one? I don't really give a hoot. Let's say we're going to stick with the same dimension. So ordinary hazard group 1. Let's say, for example, I want to space my sprinkler heads 15 feet along the branch lines. So again, I'm going to use the same numbers, 15 feet, which means off of my wall, as we already did the math, right? I'll show you the math one more time. So we've got 130 square foot coverage. I'm going to go to my chart just to show you what I am looking at. Right, we've got 130 square foot coverage. We're looking at ordinary hazard. My maximum spacing allowed is still 15 feet over here. My system type, whether it's hydraulically calculated or pipe scheduled, doesn't matter. Construction type does not matter. So ordinary hazard, this is a store, it's hydraulically calculated. I want to go with 13 feet, but I do want to utilize this 15, right? So if I'm going to go 15 feet along the branch lines, then I'm allowed to be 7'6" off of this wall over here, 7 foot 6 inches. And that means between sprinkler heads this way, up and down, we're going to go another 15 feet. I don't know if I can insert a, oh yeah, I can. Check this out. All right, here. Dope. There we go. 15 feet between sprinkler heads that way. Okay, well, we've done the math already once before. Oh, how do I undo that last little arrow? Didn't mean to do that. We're going to go back. We're going to say we have got 130 square foot coverage. I'm going to go along branch lines. Now, because this branch line is 15 feet, I'm allowed to do it for every branch line up and down on the y-axis. So I guess just to kind of show you what I mean, this will also be 15 feet between these heads. Same with this one, 15 feet. It's typical, right? Nothing's changing. 7'6" off the wall for this one. Same thing. I'm not going to get into that. 130, oh, go away. 130 square feet divided by 15, 8.6, 8 foot, 8.6, 8'6" decimal feet. 8.6 decimal feet. Yes, that's the right way of saying it. So minus 8 feet times 12 inches gives us 8'8", right? So that was my one dimension, my L, or my, what was it? What did they want us to explain here? Let me go back. Here we go. Is it our S or our L? It doesn't really matter. We just know it's S and L. Along the branch line. So if we want to get technical, this is 15 feet is equal to our S. It's along the branch line. And then L is between, right? Oh, well, there we go. We're back where we were. So yeah, 8'6", and I said this was 27 feet. Okay, so let's say we just came into this job. We are now going to start installing stuff. So I just said, oh, okay, I did my math. I know I'm 15 feet along the branch lines. I'm going to install these now 8 foot, 8 inches between the branch lines instead of along. We're going to go like that. 8'8", 8 foot, 8 inches. And then I know, now that we've figured this out, I know I can be no greater than 4 foot, 4 inches because it's half of the maximum allowable distance. So if I'm 8'8" here, then off of the wall, I'm only allowed to be 4'4", right? So if we were to add all of this up, what do we got here? We've got 8, 8, 8, 8, 4, 4, 8, 16, 20, and it'll be the same because of the last one. So that would be 21'8" overall. Where's my arrow? Let's draw. So if I were to draw from here, oh, cancel. How do I undo that? Okay, so I get it from the butt end. I get it from here to here. So from the wall to here, the wall to this branch line center, we are at 21'8". Draw text. 21'8". Cool. Well, what is this last dimension over here? I just said everything was 27 feet. I've got 21'8". So 27 from subtract 21'8" from 27. That gives us 5'4". 5'4". And here's my question. Did we install this properly? Do we still have 130 square foot coverage? And the answer is no, we do not. Why is that? And that is because of this bad boy right here, right? Me as a fitter, I came in, I'm like, all right, we're gonna go 15 feet along the branch lines. 15 feet, 15 feet, 15 feet, 15 feet, right? 15 feet along the branch lines. That's cool. And then I did my math for 130 square feet and I said, okay, I now know I need to be 8'8" between branch lines. Right, from left to right. So if I knew it was 8'8", then I said, let's install our first branch line 4'4" off the wall. I went 4'4", then I went 8'8". I went 8'8", but I didn't measure my entire room of 27 feet, and I was left with 5'4" off the wall. So if I'm 5'4" here, 5'4" times 2, right? Text. And we're gonna do the math right here. 5 foot, 4 inches times 2 is equals to 10 foot, 8 inches, right? And since we already know 8 inches is 0.6, which that is basically in brackets, that's 10.8 bar, 10.8, continued. So if I were to, oh, I wish I didn't do that. Can I move this? Can I select this? How do I do this? Oh, sick. Times 2 equals 10 foot. Yeah, there we go. That's cool. Now it's not overlapping. So that equals 10.8. So if I were, because of this one dimension, this 5'4", that one single branch line off the wall, my area of protection is actually, right? I'll actually just prove it to you. Let's just do 8 divided by 12 is equal to 0.6. Oh, I screwed this up. Good thing I checked myself before I wreck myself. Sorry. 10.6 bar. I'm not going to put bar. Just put 6 if you did. We'll just put it once. It's good enough. We all know. So I'm so happy I checked. Okay, so there we go. That's 8 in decimal inches is 0.6 plus my 10. So we got 10.6 for infinity multiplied by 15. My area of coverage for this system, just because of this one branch line being 5'4" off the wall, is actually 160 square feet. So due to being 5 foot, 4 inches off the wall, my area of protection is now 160 square feet, right? And is that acceptable? Not for ordinary hazard. I needed to achieve my 130. So this is no good. This does not fly. So when you're in the field, you need to keep an eye out for this kind of shenanigans because it's a very common thing. Guys don't realize it. And right, so that was a mistake. So now here's my next question. How do we fix this little boo-boo that we've done here? We've started installing these branch lines. How can I fix this issue? Because you know, I don't want to do this. I can't install another branch line here because we're 5'4". Well, I know I'm 4'4" here. I'm 8'8" here. What I can do is I can actually tighten up this branch line here. Instead of going 8'8", what if I went 7'8", right? Let's do that. Let's change this. We're going to now install this 7'8" center between branch lines, right? 7'8" center. All right, so now we're 7'8", we've got 8'8", and we got 4'4". We know that we have to use our largest dimension. So 7'8" is less than 8'8". So 8'8" so far is the biggest dimension. 4'4" is half of 8'8". So 8'8" is still our number. So as of now, we are still actually, I'm going to delete that. We are still actually achieving our 130 square foot coverage. 15 times 8'8" is still just shy of 130 square feet. But now that I moved this branch line over to 7'8", I can actually install another branch line here, right? 6 feet away from this one. I'm going to draw this. Oh, no, other way. I keep doing this, man. I suck at this. So here to here, let's install this 6 feet away. We're going to ignore calculations because I did not do hydraulic calculations. So now I'm 6 foot center between branch lines. Guy, come on. There we go. I'm just trying to get the point across. And that's cool. Does that, so now that I'm 6 foot center, I know 6 foot's my minimum between sprinkler heads for standard spray uprights. And now what did we achieve here? Now we've got, what was it? I was 5'4" before. I moved it over. So there's actually going to, oh, look at that. This thing worked out. There is now a 4-inch gap between the wall to center of branch line, which is coincidentally code. That's the minimum code. So yeah, there we go. So if we were to add up all of our distances, 4'4" plus 8'8" plus 7'8" plus 6 feet plus 4 inches. Just double check myself. Yeah, there you go. That's 27 feet all the way across the room, left to right. So there you go. We just added an extra branch line, 6 foot center, which is minimum code, which happens to be 4 foot. This branch line is now 4 foot center, wall to center the branch line, which is also a minimum code. And we've satisfied all of our area of protection. So we are still achieving 130 square foot coverage. Cool. There we go. I can now check that off. So this would be a proper installation. I know it would look funny, but technically speaking, by code, that is how you space them. So that would have been achieved, all right? So I gave you some examples right here. I think that's as far as I really want to go with this. Yeah, I think so. I've explained how to calculate everything. I've even showed an example of what you can do to rectify the issue if you've kind of gone overboard. I think the only thing I could do is just show you one example. I will just quickly show you one last example. I've kept going to the maximum spacing of 15 feet. So I will just actually, just before we end this video, I'm going to just show you. So let's go with ordinary hazard again, 15 feet. We know it's 130. We know our construction type and all this jazz is all. We know it's ordinary hazard. So instead of 15 feet, what if I wanted to go, I'm just going to pick a number off the dome. Let's go with 10'6". How about that? We're gonna go with a half stick. Let's go 10'7". No. Let's go 10'8". 10'8" is good. No, we already used an 8. The only reason I said 10'8" is because then I'm just thinking of our half lengths of pipe. If we're doing like 1-inch pipe, and you just put a thing to be 10'8" center. Let's go 10'6". 10'6" center sounds decent. Okay, 10 foot 6 inches center between sprinklers along the branch line, right? I don't like seeing all of this. CV. Oh, apparently I cannot copy and paste. Okay, never mind. Which means I am also 10 foot 6 inches center again down here between sprinkler heads. I really wish I drew this one extra. Ugh. Oh well. Right, that's from here to here. Right, cool. All right, well, I want to achieve my 130 square foot coverage. I've already showed everyone how to do this, but I just want to show a different number. So if I want 130, we're going to divide that by 10.5, not 10.6. That's 10 foot 6 inches. 6 inches is half of a foot. So when we're converting to decimals, 10.5 is decimal feet. So now I'm allowed to be left to right. Now my other dimension along the x-axis, 12.38 decimal feet. So that basically means 12 feet. We're going to subtract our 12 times 12 now. That's our inches. So we're now at 12'4". I'm just going to start writing this down. So 12'4". I'm going to go back to my calculator. We're going to subtract our 4 inches. We're going to go as far as eighths. I like eighths. 10'4", and we're going to round up. It says 4.58, so we're going to call it 5/8. Maybe I shouldn't round up. We're going to round down. We're going to round down just to be safe, because if I round up, there's a potential chance I might actually be, not potential, I will, because this is exact math. I will technically be over on my coverage if I went with 10'4.5" inches. So we're going to go with 10'4", 10'4" and 5/8 of an inch. So we are going to have to actually stick 10'4.5" inches. 4.5 inches, right? See, that's what I was going to round this up, 4.5. This is a decimal inch, right? Or this was my eighth of an inch. I've got 4/8 of an inch, 4.5 of an eighth. So if I were to say 5/8, I would actually exceed my coverage. So we're gonna have to stick with 12 foot 4.5. So that in decimal feet again, let's say 4.5. Oh, 4. What's going on? Oh, this mouse. 4.5 divided by 12, 0.375. So that is equal to 12.375. Right. 375 inches. Right? 4.5 over 12. Did I do the math right there? 4.5 divided by 12. Yes, 0.375 inches. Cool. And then that would mean this is going to repeat itself, 12 foot 4.5 this way, 12 foot 4.5 inches. And if I were to subtract that in half, that's 6 foot 2.25 off the wall maximum. 6 foot 2.25 wall to center of branch line. Cool. Select. Let's go there. It's pretty visible. And then just to prove my math again, what do we say? 12 or 10.5. This is just to kind of home everything in again. The measurement off the wall here, I took away the 27, but that's just how you do the math. If I wanted to go maintain my 130 square feet, but I didn't want to go to the maximum 15 feet over here. So I'm just going to check myself before I wreck myself. 12.375 multiplied by 10.5. And look at that. We got 129.9375 area, protection area for that sprinkler head, area of protection. So there you go. We achieved it, right? So I showed you different numbers that you can use. I showed you how to do the math accordingly for spacing them, right? I showed you based on the maximum, we are allowed to go 15 feet. I showed you instead of going 15 feet along heads or along branch lines, it wouldn't matter which way I went, but I said, let's go with 10'6", and then, oh, I guess I should have added one more measurement. If we are 10'6" between sprinklers on the branch line, then what are we allowed to be off the wall maximum? We're allowed to be 5 foot 3 inches. I should have written that down there. Max. Maximum. Here we go. Select. Cool. I'm sorry, this has been such a long video. I knew it was going to be like this, but, and then the last thing that I just kind of want to bring up to you before we end this, I showed you this chart. I'm not going to say it's unlikely, but just be mindful if we are talking about extra hazards, right? We cannot space our heads any further than 12 feet, right? For pipe schedule hydraulically calculated with a density. Again, this is where things get into like, how the hell am I supposed to know what density this has been calculated for? You know what I mean? Like, this is where a designer really has to step in once you start getting to these different types of hazards. Like, this doesn't mean anything to me, but if there is a hydraulically calculated system with a density of less than 0.25, then our spacing goes back to a maximum of 15. But greater than or equal to 0.25 density, your maximum spacing is 12 feet right here. So keep that in mind, because that's where things start to get a little tricky on people, right? So there you go. I've now showed you how to calculate the spacing, or how to properly space your standard spray upright and pendant sprinkler heads. I'm very sorry for this long video, but I hope you learned something. Again, this was based off of NFPA 13 2016 edition. If you are using NFPA 13 2022 edition, I do think that they changed the chapters around quite drastically. So, you know, I gave you all these code references throughout the throughout this video, but throughout the code books, it'll probably be pretty close, but it won't be the exact same thing. Like code 8.5 might not actually be position, location, spacing of use of sprinklers for a different code book. It might be now 8.6 in a different code book. So I always like to make sure I mention that I emphasize which code book I'm using because it makes a difference. So if you guys have any questions, give me a shout, shoot me a comment or whatever, and I'll do my best to get back to you. All right. So hopefully that explained it. Have a good one. Watch. I was going to say I wasn't recording. More. Stop recording.